Hey everyone, RP here, and today we'll discuss the problem called 2sum, and what exactly the problem is, and this is marked as easy in Leet Code, and I think this is the problem number one there, and the problem says that for any given array, there are many elements in this array, and you have also given some target number here. And what you need to do is you need to find out two indexes for which the sum, so basically two indexes for which the sum should be your target number. So here index 0, which is 2, and 7, so 2 plus 7 is 9. So you will return index of number 2 and index of number 7, which is 0 and 1. So that should be your output. One more thing is given here is only one solution or one combination will be there in this array. So one thing you can do here, which is kind of brute force, is for every number, like for you will start with 2 and look through all the remaining numbers here. So you will go through 7, then 11, then 15, and whenever you will find the first combination, you will say that okay, one index is for 2, another index is for 7. So in this way, say for target 26, you will not find anything with 2. So second time you will run the loop again for 7, and you will run for 2, 11 and 15. You will not find the number again. Then you will take the next number 11 and run the loop again, and this time you will run the loop against 2, 7 and 15, and that time you will find the target 26. So in that way, what we are seeing here is your total time complexity is n square, because for each number and you will do the you will run the loop against the sub-array excluding that number itself, and you will try to run for you will run and ending up running the nested array, and it will go the complexity of n square. One other approach might be hash map. So in hash map approach, what we'll do is we'll try to keep so we'll look say here is the given array. You will look through the array one by one. So first you will run read 2 here. So what you will put in the array, that number 2 you already read, and it exists on index 0. Then next number 7 stored at index 1, and so on. So you will go in that route here. So map will look like this, but at the same time, one optimization which could be done here is you will try to find the complement here. So what is complement? Say you are looking for target 17 and you are at index 0. So you have index 0 here, and it will say that 2 will the key will be 2, the number at index, and the value will be index itself. And you will try to find what is the complement here. So complement will be 17 minus 2, the difference between target and the current index number, so 15. But till now in your map you don't have 15. So you will go ahead and go to the index number 2. It will store so let me just so it will store 7 and 1. 11 will go in 2. For 7 the complement is 10. you don't have 10 in your map, you have all these values in map only. And then for 11 the complement is 6, you don't have 6 in map. For 15, which comes on index 3, the complement is 2, and yes, this 2 you have in your map already. So what you will do, you will return the index of the current element and index of the complement, which is 0. So in that, for target 17, your answer will be 0 and 3. So in that way, what you are achieving here is you are reading the elements only one time, so the complexity is order of n, as well as the space complexity. If you look at this map, for given collection of 4 elements, you are persisting 4 values here. So size of map is 4. So on space complexity side also, it's order of n. So time complexity is order of n, and space complexity is also order of n, which is much better than the complexity which we were looking at in our brute force approach. So in next video, I'll try to code it, and we'll go through how to write it in Java. See you.